So we'll learn how to draw a Newman projection for a cyclohexane. So here's how I like to start. The chlorine is pointing up, and there is a methyl pointing down. Okay. And then in the front, there is a methyl pointing up, and there is a methyl pointing up as well. Now let's try to assemble this. For this carbon, there's also a hydrogen pointing up, and that's going to be in the front because this is going to be our carbon reference number 1. So this will be in the front. That means this methyl is in the front as well. So that must mean the chlorine is in the back because it's not immediately bonded to this first carbon. So that's going to be in the back. And the front, this is just going to connect to the other side, so no biggie. However, what do we put down here? Now remember, whatever is behind our circle means it's not the carbon that's in the front. So it's going to be in the carbon that's in the back. So in our situation, there's going to be a hydrogen poking down because there's no other substituent around. So because a cyclohexane usually looks like this, so the other thing that can be pointing down can only be hydrogen. And then the back here is also just going to be connected to the other Newman structure. Now let's draw our second Newman structure, which is going to be the carbons in the front. We mentioned that there is a methyl pointing out, so this is going to be our front. Okay, this is going to be our front, and because this methyl in the back is not connected to our first carbon of reference, it's going to be in the back, and this side is going to be connected to that, and we need one more thing down here. And what can we have? So we already said that this is, hang on, so this corner is just this corner that connects the blue and the pink, and there's nothing there. So then that must mean the other thing that's connected to this central carbon is going to be a hydrogen. What about our back? So our back, we already have this on the other side, so our back carbon is going to be this because it's attached to the methyl. So therefore, we got our methyl, we got our connectivity here, so this corner is going to be this. So then the only thing that makes sense to add down here is a hydrogen because this carbon, this back carbon, is already bonded to the highlighted yellow part. It's already bonded to the methyl, and now all that we have down here is a hydrogen. So the answer is going to be A, but let's step back for a moment and see what we actually did around here. So it kind of depends on the angle of the question that they give you, but in our problem here, this was carbon 1, and this was carbon 2, which was in the back. And then this is our carbon 3, this was our carbon 4, which is also in the back. I'll add a bracket for the backs. And then 5 is our front carbon, and then 6 is like this. But it really depends on the question they give you, and because this is a multiple choice, it's a little bit easier. The hack that you can do is you see that chlorine is pointing up, so this is the only option that has chlorine pointing up. The rest has chlorine pointing down, which is not good. So that's how you do it.